Let's continue. For example, 8.3 about a uniform ladder. First, we need to draw all the forces acting on the ladder.
Let's solve this problem. A uniform ladder AB. Your ladder from A to B, the length is given by 10 meter. Okay, and then this ladder, the mass of the ladder given by 5 kg, and then leans against a smooth wall. Smooth wall. This is your smooth wall. Instead, no friction here. Smooth wall. The height of the end of the ladder, the height of the end of the ladder is 8, given 8 meter. Okay. Then from the rough floor. Now what we have to do, the first thing is to find center of gravity. How to get center gravity? CG, this ladder length 10 meter divided by 2 means that your center of gravity here is 5 meter. And also here is 5 meter. A to center gravity or center gravity to B is 5 meter. Midway. Okay. Then divide by 2. Then you must put center gravity here. Okay. Dot. With the label dot. Then take your ruler. Take your ruler. From the CG, we must draw width of the ladder. Go straight, and then this is your width of the ladder. First thing you have to do is to find the weight of the ladder from the CG, center of gravity. The second one is when the ladder leans against the wall, means that the ladder touch the wall. When the ladder touch the wall, here we will have normal force which is perpendicular to the ladder, to the surface. This is your normal force at A. Also same goes to B. Okay, when the ladder touch the floor, then we will draw normal force at point B is upward. This is NB. You see, perpendicular to the surface, which is floor. And then we have another force which is friction, because we have rough floor here. Then we have friction. As you can see, when the ladder is falling down, okay, when the ladder is dropped, at the end of B, the ladder will move to the right. And then for the ladder at the A point, the ladder will drop to the downward. Okay. Then when the motion is to the right for point B, then our friction will be oppose the motion. Then friction at B we have here. The direction is opposed to motion. Then this is our friction. Okay. This is our friction. Same goes to wall. If the wall is a rough wall, then your friction will be upward. But in this question, your wall is smooth wall, means that no friction. Okay, there's no friction at the wall. There, this is your forces. Then the question tell us that we need to draw another force for firefighter, which is the firefighter is from 3 meter from B. 3 meter, as we know that from B to CG is 5 meter, means that halfway is 1.5. We estimate that our firefighter is around here, 3. Okay, and then again we draw the weight. of the firefighter. This is our weight of firefighter. That's it. That is all forces acting on the ladder. You should know how to draw the forces acting. Okay. From here we know that we have angle, which is from, as you can see when I draw a line here, you will see the angle between here, between the line and the force is here, we used to be alpha. Okay, when here is alpha, then the here is beta. Then we need to find alpha and beta angle. Okay, alpha and beta angle. As you can see, this alpha angle is same to this angle. Okay, which is here also alpha. Okay, if we want to find the sine alpha here, we need to use this trigonometry. This trigonometry. Okay, we have 10, we have 8, and here is 6. Okay, then we will find our sine alpha from this one. Sine alpha is 8 over 10. Then sine alpha is 0.8. For sine beta is equal to, also is equal to 6. Then we get 0.6. Sine beta, if you want to have a theta beta, instead shift sign 0.6. After that, this beta is same to here and here, because beta here is also same as here. Okay, when you see here to here and to here, then you will see the beta is the same. Okay, that's all for the diagram.
This question needs you to determine the horizontal and vertical forces exerted on the end B of the ladder when a firefighter of mass 60 kg is 3 meter from B. We just draw all the forces acting on the body. Horizontal forces, which is at the end of the B, is here. Horizontal forces, which is friction. This is horizontal forces at B. Then vertical forces. This is our vertical forces at B, which is NB, normal force at B. Means this question need we to find NB and F, friction. Horizontal for friction, vertical for NB. How to solve this problem? After we draw all the forces, then to calculate, first we need to use two conditions to solve this problem. Two conditions, which is total torque equal to 0, total F equal to 0. Then let's use the first one, which is total Fx equal to 0 and total Fy equal to 0. First condition. Okay, total Fx we have here friction, x-axis. Friction is x-axis. How we know the axis? This is y-axis, this is x-axis. Same goes to these forces. Each item or each forces, just draw the axis. Then we will see we just have total Fx. We just have friction here, and then normal force A here. Means that when we write the equation, F is negative direction, means that NA minus F equal to 0. Then NA is equal to F. We can solve this problem because we didn't have the value of NA. Then another condition is total Fy equal to 0. Fy we have NB, WF, WL. 3 forces. Then 3 forces and B is upward, means that NB positive, NB minus WL minus WF equal to 0. Then NB is equal to MLG plus MFG, mass of ladder and mass of firefighter. Mass of ladder given here, mass of ladder is 5 kilogram. 5 times 9.81 plus mass of firefighter given 60 kilo, means that 60 times 9.81. Then NB will get 637.65 Newton. Then this is our answer for vertical forces. To solve another problem, which is friction, we need to use our second condition, which is torque. Total torque AC is equal to total torque C. First, we need to do is to find pivot point. Pivot at any point. Choose any point you want to pivot, either at CG, at the end of B or A. I choose here. Why I choose here? Because when I choose point B, all forces here, total torque is 0. Then I don't need to find NB anymore because I just have NB. I just need to find NA to get friction. Okay, pivot at point B. Write your pivot point atau pivot point. Pivot at point B. When I pivot at point B, okay, total torque AC is equal to total torque C. We know that torque is equal to FD, or you can use torque equal to FR sine theta. Theta noted here, theta is angle between F and R. Okay, find torque is from the axis of rotation here. Now this is our pivot point, which is axis of rotation. First force here, this is our R, this is our force. This is our R, this is our force, this is our beta or theta. Remember, theta here, FR sin theta, torque is equal to FR sin theta. Theta here is angle between F and R, force and R. Then this here, from the axis of rotation, this is our R. This is our first force, which is weight of firefighter, and this is our theta, which is beta. This is our first torque, which is torque for firefighter, torque F. I label it as torque F. Then second one is second force here, from here to here. This is our second torque because this is our force WL, this is our theta ataupun beta, and this is our R, L. Then is our torque L there. Then another forces is here. Then this is our R, this is our theta, and this is our force NA. Then we have 3 forces, Tn. I labeled it as TNA. We have 3 torques here. Then now we need to know that torque here, torque F the direction of rotation of this force, torque L, and then this torque, the direction of rotation. Which direction that the force will rotate. For this force, TF, when you pull or push the ladder from the pivot point, the ladder will rotate anti-clockwise. We rotate like this. For these forces, also, from the axis of rotation, the ladder will rotate anti-clockwise. For this torque, it will rotate clockwise. Then we have two torque, which is this is anti-clockwise, and this is clockwise. Then just rearrange. We have here torque AC, we have two, which is torque of firefighter plus torque of ladder, equal to, again, it will rotate like this anti-clockwise, and this will rotate this anti-clockwise, and this torque will rotate like this is clockwise. Okay, then arrange the torque F plus torque L equal to torque and A. Then we know torque is equal to Fr sin theta, because we want to use this one. If we want to use the one, D must perpendicular to F. For right now, our R is not perpendicular. Perpendicular is when you resolve to this one. Then this force will be perpendicular. WF sin beta, for example. I just need to use this one. WF. This one is our R. This one is our beta for torque F. Okay. Then just write our F here for torque F. Our F is WF R sin, our theta is beta, plus for torque L with ladder times R sin also beta. Then is equal to torque NA is NAR sin for NA sin alpha. Then WF given mass of firefighter means that MFG R sin beta plus MLG R sin beta equal to NAR sin alpha. MF mass of firefighter given 60 kilo. Is it 60 kilo? Yes, 60 kilogram. Then 60 times 9.81. R is from the rotation axis to the force, to the applied force from here to here. This is our R. As dimension, our R here is 3 meter. 3 meter, then this is 3. Sin beta, as we calculate before, sin beta is equal to 6/10. Then our sin beta is 0.6. Sin beta is 0.6. Plus mass of ladder is 5 kilogram. 5 kilogram. 5 times 9.81. R ladder, here center of ladder is, the center is 5. Sin beta is 0.6 as we calculate, equal to NA. We need to find the NA because NA is equal to friction. R is length of the length of the ladder, which is 10. Sine alpha as calculated before is equal to alpha here is same as here, means that 8 over 10, which is 0.8. Sine alpha is 0.8. I didn't convert to the degree. I just use sine alpha. Okay, then calculate NA. You will get NA is equal to 150.829 Newton. Then NA from this equation, NA is equal to F. NA is equal to 150.829 equal to friction. Then friction is equal to 150.829 Newton. This is our horizontal force. That is the answer for first questions. Okay, for question B, again, draw the free body diagram for this ladder. For force before is the same, just the difference is firefighter is at 7 meter up the ladder. Okay. First of all, we draw our basic forces acting on the ladder first, which is we have here our CG here, center of gravity, which is WL, and then we have normal here, normal. Okay, this is our normal force for A, and then we have here normal force for B. Okay, exactly same as the first one. The friction also, friction, and then our firefighter 7 meter. 7 meter is, we know that our length of this ladder is 10 meter. At the center, okay, at the center from here to here is 5 meter, means that 7 meter is around here. Okay, around here is our firefighter. Okay, our firefighter is here. This is our weight of firefighter, which is distance from here to our end of this ladder. Here is 7 meter. Okay. Okay. Then this question needs me to find mu of the friction, static friction. Okay. Now here also same as we calculate first the value of alpha here and the value of beta here, means that here is beta and beta, because here is beta, here is alpha. Okay, let's start. First, we use first condition first, which is total F x equal to 0 and total Fy equal to 0. Here we have F against negative x direction and A positive. Okay. Now NA is minus to F equal to 0 and A is equal to F. Again, our first equation. And then
For Y, here NB positive, WL and WL. Then NB is equal to WL plus WF. When we rearrange the equation, we will get this one lah. Then here we will find NB is ML plus MF times G. Then NB against we will get the same as before, which is L5 plus 60 times 9.81. When we calculate NB, we will get 637.65 Newton. Okay, this is NB. We need to find NA using second method, which is total top AC equal to total top C. Remember, for the top, you need to know that we must to find first pivot point. Okay, pivot point. You can add the pivot at these 3 points, whether here at point A, at CG, or at B. You can choose either one. Okay. If you solve the problem, then you will get the answer at the exactly point. If you didn't get the answer at any of other point here, just change your pivot point and calculate again. Try and error. Okay. Here I will pivot against. I will pivot my pivot point at B. Also at B. Here I will pivot at here. When I pivot at here, for this NB, there is no top. Also goes to friction, there is no top. I have this one because from the axis of rotation to the first force, we have WL as force here, F and R here, and this is beta or theta. Then we have here first top L. And then also from axis of rotation to here, second force here, we have force, and then we have R, beta here, then also we have top 2 here. As we know, top is equal to FR sine theta. Theta here is angle between F and R. If we have F, R and sine theta, then we have top. Okay, let's see another force there. Last force is here, which is NA. We have alpha and we have R here. We have NA as force, then FR sine, then we have another top here, top and A. We have 3 top here. Okay, then we need to find the direction of top, whether anti-clockwise or clockwise. Now, to find the clockwise, the top anti-clockwise, we need to see the force acting. As you can see here, top 1 here, this is top 2 and this is top 3. The position is here, means that it will rotate this way. Okay, when we push, it will rotate this way. Then this way is anti-clockwise. Also goes to this second top. When force push the beam or the ladder, this is the axis of rotation, then it will rotate this way. And for W here, the rotation is anti-clockwise. Then top F, top L, anti-clockwise, top F also anti-clockwise. Then the last top here, it will rotate From this of rotation axis, rotate clockwise. Then torque NA here is clockwise. Then we have anti-clockwise, anti-clockwise, and clockwise. Then just rearrange. Okay, torque anti-clockwise, we have torque L plus total plus torque for firefighter equal to torque and A. Then torque is equal to FR sin theta. F here for L is W. WL. Sini Torque is F. Ingat. Remember. Torque is equal to FR sin theta. Theta angle between F and R. Then torque here, I can write here. For F is MLG or WL sin, WL for F, okay. Then R is R. Then sin here for L is beta. Then beta. Plus torque F is WF R sin also beta equal to torque bagi NA is NA R sin alpha. Okay, this one is alpha. Okay, WL is MLG R sin beta plus MFG R sin beta equal to NAR sin alpha. Again, sin alpha, as we calculate before, sin alpha is 8 over 10, which is 0.8. Sin beta is 0.6. Okay, then here when we substitute the value, because we want to have NA here, the difference here is the distance exactly. The distance for MF. For MF, the distance is changed to 7. Before this, the distance is 3. Okay, M, same, mass of ladder against 5. 9.81. R is 5. Sin beta is 0.6 plus MF 60 times 9.81. R here is 7. Okay, sin beta is 0.6. Then NA R is 10, 0.8. Then we will have NA here. You will get NA okay. You will get NA here. NA is 32,737.41. Then from here, from equation 1, which is NA is equal to F, okay, NA is also equal to mu NB. Why? Friction is at the floor. Friction is at here. Then it's experience normal B. Jadi NA is equal to mu NB. We have to find mu, then mu is equal to NA over NB, which is NA 327.41. NB, from here we get 637. 637.6. 367.35. Okay, then we will get 0.51.